So in this section, we will observing the effect of modulation order on the performance of the system. To do that, we will first fix the transmission power to minus 50 dBm, and we will be changing the modulation formats from the one with the lower modulation order to the one with the higher modulation order. And we will be observing the changes on the EVM and also on the I diagrams. So let's go to the VSG and do the parameter setups. First of all, we want to transmit at minus 50 dBm, so we will change the amplitude to minus 50 dBm, and also the first modulation format we want to use is QPSK, so we will go to the mode here. Modulation type, the QPSK is already selected, so you don't have to do anything else. We can just allow the device to start transmitting. Now at the receiver, the digital demodulation parameters are already set up from the previous section, so we don't have to change anything. So we are required to observe the number of levels on the I diagrams, on the Q and I diagrams, and make a comment on them as the modulation order change. So one thing I want you to note is that, like, these levels that we are seeing on each of these I diagrams correspond to the number of amplitude levels that you have on the signal. For example, in this case of the QPSK, we have in the I axis we have 2 levels of amplitude, and also on the Q axis also we have 2 levels of amplitude. So these are reflected here on the I diagrams as 2 levels. So as we increase the number of levels by increasing the modulation order, the number of levels that we will be observing on the I diagrams will be increasing, as we will see in the next modulation format. So in order to do this comparison for all the modulation formats mentioned in the manual, we will save the screenshot for each case, and then you will attach these screenshots on your report and make comment on them. So to save the screenshot, we can easily go to the file here, select save, and then select the save bitmap. Here make sure you select window and say save. So we will save this on the desktop of the VSA. We can simply create a new folder here on the desktop and call it lab 3, and we can name this, the first screenshot, as section 2 QPSK. So it will be saved as a JPEG. So we can double check that. So it is here, and our screenshot is saved here. So now we will go and do the next modulation format, and then you will repeat the same thing. You will save and make the comment as required. So we can go to the VSG and change the modulation type now to 16 QAM. So we'll go to the QAM here and then say 16 QAM, and that's it. So here now we have to change the modulation setup by going here again, and now we have to switch from QPSK to 16 QPSK. Which is here. We don't have to change anything else because the symbol rate and the filter parameters remain the same. So as you can see, like when we increase the modulation order, here the number of levels increase. Now we have 4 in each axis. The same way here on the I diagrams, 4 levels are reflected, and the EVM is decreasing. So you have to make the comment on this. One more thing that you can note, like when you increase the modulation order, the constellation becomes gets closer to each other. That means the region around each constellation now is reducing. So that means if the noise is too much here, you can easily make error, because the sample that belongs to one constellation can be easily transferred to the nearby constellation, because now the constellations are closer to each other. So you can again save this one by doing the same by following the same procedure as I showed you before. Go to the file, save bitmap, select window, and again you can save this one. So this is 16 form. Now it is done. So we can do the same thing for the next modulation format. That we can go to the VSG and select here QAM and 64 QAM and allow the device to transmit. Again here we have to change our demodulation parameters to 64 QAM, which is here. So as you can see now, when we increase the modulation order, the constellation gets closer to each other, and also the levels here gets closer to each other as well. And it's even difficult to distinguish them. The eyes are almost closed because of the noise, and also the EVM is getting lower. So you will save this again and attach them to your report along with the comments that you are supposed to provide. So after this, we'll move to the next section. In the third section, we will investigate the effect of crossing through the origin. In the polar diagrams for different modulation formats. We'll consider four modulation formats, which is QPSK, offset QPSK, pi over 4 differential QPSK, and MSK signal. So in this case, we have a different transmission and reception parameters. We need to set them, and we will do the analysis on the two different domains, like in the digital demodulation analysis, and also we will do analysis on the vector analysis mode. In the digital analysis, we will consider similar plots like we had before, and we will focus on the number of constellation points, behavior of transition between symbols for each modulation type, and also we'll see how the eye diagrams changes for each of the modulation types, and also the characteristics of the spectrum for each of these modulations. Remember that all of this modulation, they have 4 constellation symbols, basically, because both of them are derivative of the QPSK, but they will have some different characteristics in terms of number of constellation, and also behavior of the transition, as well as the other things, because they are generally developed to overcome the problem of zero crossing, the crossing through the origin. So we will observe that. And in the vector analysis mode, also we will consider the CCDF, which we will be observing the PAPR, and also the time domain signal, the envelope, which will show us the dynamic range of the signal. So we can now go to the VSG and do the parameter setups. We are required to set the transmission power to minus 30 dBm, and we need to set the roll-off factor of the same filter we have to do the roll-off factor of 0.95 enter. The symbol rate is 100 kilosymbol per second. And the modulation type should be, we will start with the QPSK. So here we select the QPSK, and Everything is now set, so we can start transmitting the signal. Now at the VSA also we need to set the proper reception parameters. First of all, we need to change digital demodulation properties. We need the modulation to be QPSK, and the symbol rate is 100 kilohertz, already set, and the filter roll off is 0.95, already set. Also we need to change the span to 400. So now we are receiving the signal correctly, as we can see here. So we are supposed to observe the number of constellation points, behavior of transition, eye diagrams, and the side lobes from the spectrum. So as we can see here, we have 4 constellation points for the QPSK, which we could expect. But also we have this zero transition, I mean the transition through origin here, which causes the large amplitude variation in the time signal. Here we can plot the time signal from this window. We don't need this one. So we can plot the, so we can see the transition here. Let me make it auto scale. You can see the amplitude variation, and we will compare this with the other modulation type, and we will see the changes. So we can save this one as I showed you before by doing the same thing. We can save the bitmap so that we can compare it later with the other modulation formats. So this will be section 3 QPSK. Now at the VSA we need to reset our modulation parameters, so we will go and change the modulation format to offset QPSK now. And now we are receiving everything correctly. So you can see here, like the QPSK avoids the transition through the origin, which makes its envelope, less variation on its envelope here, as you can see in the time signal here. And also you observe the extra number of constellation because of the offset that has been introduced into the I and Q component of the symbol, and this offset can be also observed from the eye diagrams, like this eye diagram and the QI diagram. They have the offset of about half a symbol period. So you will again take the snapshot of this one, save it, and you will include it in your report alongside the comments. Now we will go to the VSG and generate the next modulation format that we require, which is pi over 4 differential QPSK. Now again we need to readjust our modulation format here, which should be pi over 4. Differential QPSKs here. So again, the differential QPSK avoids the transition through the origin, but the transition somehow comes closer to the origin compared to the offset QPSK, as you can see. So that also you can see from the time signal here, which has a relatively higher dynamic range compared to the offset QPSK signal. Also, we have extra number of constellation that we are observing. This is because, as you have seen in the lecture, we are using two QPSK constellation patterns here, being switched at each symbol period at 45 degrees. That's why we are seeing extra number of constellations here. The same, you can see that switching also in the eye diagram here, like there is this one and there is this one. Now let's observe the last one, which is MSK. So we will transmit MSK from the transmitter here. Now the MSK signal is being transmitted, so we will again readjust reception parameters, MSK. And remember, for MSK we have some extra requirements. For the receiver, we need to make sure that the receiver filter is off and the reference filter is RRC. So let's do that. So the measurement filter, the receiver filter here, make it none, and this one should be RRC. So again, this is a MSK signal. As you can see, it is completely the transition from one symbol to another have completely the same amplitude from the origin. If you can see, it is a circle. It is a circle, and this is reflected in the time signal here. You can see the envelope is almost constant. That's why it is called the constant envelope signal modulation. So this is the best among the, if you compare among the four of them. But one disadvantage of this modulation format is that it has some side lobes that makes it occupy a larger bandwidth compared to the other modulation formats. So again, you will take the screenshot of all this, save them, and include them in your report. Finally, we need to repeat the whole thing and do the analysis from the vector mode. So I will do only two of them, since we are already receiving MSK signal, so we can begin with it. So we will change the measurement type to vector. In this case, we only need two windows, one for time signal and one for CCDF. So as you can see here, the MSK envelope is almost constant, and this is its CCDF curve. So we will change the modulation format and see the changes on the envelope and also on the CCDF curve. So let's do that. We can now change to QPSK, for example. You can select QPSK. So as we can see now, the envelope is no longer constant. It has, the dynamic range has increased, and also the CCDF also has increased compared to the previous one. And also remember, when you are changing the modulation format, in this case, you don't have to change your demodulation parameters because we are not in the demodulation mode. We are working from the time vector mode now. So the same way, you can take the screenshot of the results, and you can also analyze other modulation format. For example, let's say we can see pi/4. So you can see the changes. The dynamic range is somehow improved compared to the QPSK. And also we will observe there is a small change in the CCDF as well. So you will do the same thing for the offset QPSK and take the snapshots and include them in the report.